Good morning, my dear students of first secondary. Today we are going to study geometry, and our lesson today is called Similarity of Triangle, second case and third case. Let's start. Follow similarity of triangles. Second case. Theorem 2. SS similarity theorem. If the side lengths of triangles are in proportional, then the two triangles are similar. So the second case of triangle, if the three sides of the first triangle are proportional to the three sides of the other triangle, then the triangles are similar. Okay? Third case, SAS similarity theorem. If an angle of triangle is congruent an angle of another triangle and the lengths of the sides including those angles are in proportion, then the triangles are similar. Let me explain a two theorem for you. Here, if we have two triangles, triangle A, B, C, and triangle X, Y, Z. Okay? If you find that AB over XY equal AC over XZ equals BC over YZ. So you can say that the three sides of the triangles are proportional. The sides of the triangles are proportional, then the two triangles are similar. This is the second case. And what about the third case? Here, the third case, if ABC is a triangle and XYZ is another triangle, if measure of angle A equals measure of angle X, here if an angle of triangle is congruent to an angle of another triangle, so if measure of angle A equals measure of angle X, okay? And the lengths of the sides including those angles, here you have to notice that the lengths of the sides including those angles are in proportional, then the triangle are similar. So here you are going to compare between AB over XY and AC over XZ. The two sides including angle A and angle X. So the three conditions are, if measure of angle A equals measure of angle X and the two sides AB over XY and AC over XZ are proportional, that is to say that AB over XY equals AC over XZ, then we say that the triangle ABC is similar to the triangle XYZ, as we are going to see in the following examples. Okay? Example 1, in the opposite figure, B, Y, and C are collinear. Prove that triangle XBY similar to triangle ABC and BC ray bisects angle ABX. Okay, let's start the example. Here ABC, just a moment please. Here B, Y, and C are collinear. B, Y, and C are collinear. That's to say that B, Y, or C are on the same straight line. we want to prove that triangle XBY is similar to triangle ABC, and BC bisects angle BC bisects angle ABX. Okay? In this case, you can see that you have all the sides of the triangle XBY, and we have all the sides of triangle ABC. Okay? So, to know that this is the third case of similarity, you will find all the lenses of the triangle XBY and all the side lenses of the triangle ABC. Okay? So, how we are going to know the proportional side? Here you can see that we want to prove that triangle XBY similar to triangle ABC. Okay? So we are going to find XB over AB. Okay? We are going to calculate XB over AB, the first two letters of the first triangle and the first two letters of the second triangle. XB over AB. You can see that XB, its length equals 9, AB, its length equals 12. 9 over 12, by put it in the simplest form, it will be 3 over 4. So XB over AB equal 3 over 4. Okay? So we are going to find BY over BC. BY over BC. BY, what is the length of BY? BY equals 18 over BC. BC, it will be 18 plus 6. So this equals to 24. Put it in the simplest form. Divided 6 equals 3. Divided 6 equals 4. And the last one, we will find the ratio XY over AC. So here XY over AC. XY over AC. XY, its length equals 13.5 over AC, its length equals 18. By using your calculator, put it in the simplest form, it will be also 3 over 4. Okay? So now all the corresponding sides are proportional. XB over AB equals BY over BC equals XY over AC. All the sides are proportional and its ratio equal 3 over 4. So we can say that the triangle XBY similar to triangle BYC. Okay? So again, by using the PowerPoint, here we have XB over AB equals 9 over 12 equals 3 over 4. BY over BC equals 18 over 24, which is equals to 3 over 4. Okay? And XY over AC equals 13.5 over 18. This is equals to 3 over 4. Here I used that. He wants me to prove that triangle XBY is similar to triangle ABC. So I find XB over AB and BY over BC, and the last one XY over AC. And you can see that all the side lengths are proportional and each ratio equal 3 over 4. Okay? So the triangle ABY is similar to the triangle ABC, similarity third case. Okay? And from similarity, you can find that measure of angle X here in the first triangle is equals to measure of angle A in the second triangle. So we will write measure of angle X equals measure of angle A. And measure of angle XBY, measure of angle XBY here is equals to measure of angle ABC. ABC. Oh. Measure of triangle X, measure of angle XBY equals measure of angle ABC. So here the two angles are equal in measure. That is to say that CB ray bisect angle ABA, XBA, which is the second required. Okay? So now from similarity we have measure of angle XBY equals measure of angle ABC. So BC bisects angle ABX. Okay, let's go to another example. Example 2. Example 2. BC intersect DE equals F, AB equals 6 centimeter, BC equals 12 centimeter, and you have the lenses of all the sides. Okay? He wants to prove that triangle ABC is similar to triangle DBF. And he wants to prove that triangle EFC, the smaller one, is an isosceles triangle. Okay? Okay. By using the same way, first you have to check that all the sides of triangle ABC is known. You know all the sides of triangle ABC. ABC, AB equals 6 centimeter, BC it will be 9 plus 3 equals 12, and AC is 8 centimeter. Okay? And you know all the sides of triangle DBF. BF equals 9, FD equals 6, and DB equals 4.5. Okay? So you know all the side lenses of the two triangles. So by using similarity, okay, we are going to find AB over DB and BC over BF, and the last one it will be AC over DF. Okay, let's solve it together. Here AB over DB. AB equals 6 centimeter over DB equals 4.5. Okay, put it in the simplest form. Here divided 15, it will be 3 over 4. Okay, 3 over 4. And BC over DB. Okay, BC over DB. BC over BF. Sorry. BC, the second two letters, BC over BF. Okay, here we have BC, its length equals 12 centimeter over BF 9 centimeter. Put it in the simplest form. It will be divided 3, it will be equals to 4, divided 3, it will be equals to 3, 4 over 3. So the first one, if we put it in the simplest form, put it in your calculator, 6 over 4.5. 6 over 4.5, it will be also 4 over 3. Okay, so we have 4 over 3, and the last ratio will be AC over DF. AC over DF. AC, its length is 8 centimeter, and DF, its length is 6 centimeter. Put it in the simplest form, so it will be 4 over 3. So now you know that all the corresponding sides of the triangles are proportional, so the two triangles are similar. Okay? Here we want to prove that the triangle EFC is an isosceles triangle. Okay? Let's solve the first step, the first requirement together by using the PowerPoint. Here AB over DB equal 6 over 4.5, and it will be equals to 4 over 3. BC over BF equals 12 over 9 and equals 4 over 3. And the last one, AC over DF, it's equals to 4 over 3. All the corresponding sides are proportional, so the triangles are similar. Okay? Let's go to the second requirement. We want to prove that triangle FEC or EFC is an isosceles triangle. From the first requirement, from similarity, you can see that measure of angle A here is equals to measure of angle D. So measure of angle A will be equals to measure of angle D. Okay, and measure of angle B in the first triangle is equals to measure of angle B in the second triangle. So measure of angle B here is equals to measure of angle B in the second triangle. So also you can say, as the previous example, that CB bisects angle ABD, but this is not required in this problem. Okay, and measure of angle C, the last one, is equals to measure of angle F. So measure of angle C in the first triangle here is equal to measure of angle F. Okay. But we all know that measure of angle BFD is equals to measure of angle EFC, vertically opposite angles. Okay. Again, here you know that measure of angle F in the first triangle, okay, is equals to measure of angle C in the second triangle. Okay. And you can see also that measure of angle FBD is equals to measure of angle EFC, vertically opposite angle. Okay. So now measure of angle ECF is equals to measure of angle EFC. So the triangle ECF is an isosceles triangle. Okay. Let's solve it again by using the PowerPoint. Measure of angle ACB, measure of angle ACB here is equals to measure of angle DBF, DFB, okay, and the measure of angle DFB is equals to measure of angle EFC, vertically opposite angle from 1 and 2. Measure of angle ECF equals measure of angle EFC, therefore the triangle EFC is an isosceles triangle. Okay. Let's go to another idea. Theorem 3. The ratio between the areas of the surfaces of two similar triangles equal the square of the ratio between the lengths of any two corresponding sides of two triangles. So, if you have two similar triangles, if we have two similar triangles, okay. So, if triangle ABC is similar to triangle XYZ, okay, we all know that perimeter of triangle ABC over perimeter of triangle XYZ, the ratio between the two perimeters equal the ratio between any two corresponding sides, equals any two corresponding sides AB over XY. Okay, this is from the first lesson. But here in this theorem, he tells you that area of triangle ABC, area of triangle ABC over area of triangle XYZ, the ratio between the areas of two similar triangles or two similar polygons is equals to the square of the ratio of any two corresponding sides. So this is equals to AB over XY for all power of 2 is equal to the ratio between any two corresponding sides. Okay. So the ratio between the perimeters of any two similar polygons equals the ratio between any two corresponding sides. But the ratio between the areas of two similar polygons is equals to the square of the ratio of the corresponding sides of the triangle. Okay? Okay. Example. If the lengths of two corresponding sides in two similar polygons are 6 cm and 8 cm. This is the lengths of two corresponding sides in two similar polygons are 6 cm and 8 cm. And the area of the bigger polygon equals 144 cm. Find the area of the smaller polygon. Okay, let's solve it together first. Here we have two similar polygons. There are two similar polygons. So the ratio between polygon 1, area of polygon 1 over area of polygon 2 is equal to the ratio between two corresponding sides. And the corresponding sides are 6 over 8. You can put it in the simplest form. This is equals to 6 over 8 for all power of 2, the ratio between the square of two corresponding sides. You can put it in the simplest form, so it will be divided 2, it will be equals to 3, and divided 2, it will be equals to 4. Okay, so the ratio will be 3 over 4 for all power of 2. Okay, okay, and he tells us the area of the bigger polygon is 144. So how can I know the area of the bigger polygon? The area of bigger polygon is corresponding to the large side. So we can write that area of polygon 1 over area of polygon 2, which is equals to 144. This is equals to the ratio between two corresponding sides, 9 over 16. So to find area of polygon 1, cross multiplication. So area of P1, it will be 9 multiplied by 144 over 16. Okay, let's solve it again together by using the PowerPoint solution. Area of polygon 1 over area of polygon 2 equals the ratio between two corresponding sides, power of 2. Okay, area of a smaller polygon over area of large polygon. Okay, the area of large polygon is 144 because it corresponds to the larger side. Okay, so this equals to 6 over 8 for all power of 2. Put it in the simplest form, it will be 3 over 4 for all power of 2. So we will write it again. Area of smaller polygon, this is equals to, you can see that 3 over 4 power of 2 equals 9 over 16. Cross multiplicate 9 over 16. Okay, area of smaller polygon over 144 equal 9 over 16. Cross multiplication, so the area of the smaller polygons equals 9 multiplied by 144 over 16, which is equals to 81 centimeter square. Let's go to another example. Example 4, in the opposite figure, AE bisects angle DAB, area of triangle ADE equals 12. Find the area of triangle ABC. Okay, here we are going to apply the similarity second case, the similarity third case, and we are going to apply the rules of the area. Okay, you have to know that to find the ratio between the areas of two similar polygons, okay, they must be similar. So first step, you have to prove that the two triangles are similar. Then the ratio between their areas equals the ratio between the square of any two corresponding sides. Okay, here we want to find the area of triangle ABC. We want to find the area of triangle ABC, and the area of triangle ADE is given to us, and it's equals to 12 centimeter square. Okay? Okay. Here, let's solve it together first. Here, you can see that measure of angle DAE equals measure of angle CAB. So you have angle equal angle. Measure of angle DAE equals measure of angle CAB. Okay? And you can't find another angle equals to another angle in the second triangle. Okay, so we can't apply similarity theorem first case. Two angles equals two angles, and we don't know all the side lengths of triangle ADE, so similarity second case is not verified in this case. So we are going to use similarity third case. What is the similarity of third case? You have to find measure of an angle equals to measure of an angle, another angle, okay? And the two sides including the first triangle is proportional to the sides including the second angle. So here, what are the sides including first angle, which is DAE? The two sides are, we have 6 and the second side is 8. Those are the enclosing side. One of them is 6 centimeter and the other is 8. And what about the angle of the second triangle, which is CAB? The enclosing sides, one of them is 8 plus 4, 12 centimeter, and the other one is 9 centimeter. We are going to put the smaller side under the smaller side. So we write 9 over 6. And the bigger side here, which is 8 in the first triangle, corresponds to 12 in the other triangle. So it will be 8 over 12. Now you can find the ratio between 6 over 9. Here we will find DA, the first side in the first triangle, over 9, which is AB, the second side in the second triangle. It will be 6 over 9. Put it in the simplest form, divided 3 equals 2, divided 3 equals 3. Okay? And the bigger side over the bigger side, 8, which is AE, over the bigger side in the other triangle, which is 12 centimeter AC. You will find that its ratio will be 8 over 12. Put it in the simplest form, divided 4, it will be equals 2, divided 4, this equals to 3. So you can see that first measure of angle 1, measure of angle DAE equal measure of angle CAB. And the two corresponding sides are proportional. The two corresponding sides are proportional. So the two triangles are similar. Okay? Okay. Let's solve it again together by using the PowerPoint, and I will explain to you again. Okay? Here, solution. First, measure of angle DAE equals measure of angle CAB. Okay? Angle equal angle. And what about the enclosing sides? AD over AB. AD over AB. Okay? So, we will erase C. AD over AB equals 6 over 9 equals 2 over 3. And AE over AC equals 8 over 12 equals 2 over 3. Okay? Here we can find that AD over AB equals AE over AC. This is number 2. The corresponding sides are proportional. From 1 to 2, therefore, triangle DAE is similar to triangle BAC. Mister, how can we arrange the vertices of triangle? Here we don't know the arrange of the triangle. Here we have to write the corresponding vertex together. Okay? Let me explain it to you. Okay? Here let's choose another color. Here we know that DA, it's still red. Here DA here the two letters DA. DA, the side is DA. What is the corresponding angle? The corresponding angle here is E. Okay? It's still red also. Here the corresponding angle is E. And what about AB? AB, it's the side length AB is corresponding to angle C. Okay? So you will write triangle. Write the first one as you like. The first one will be triangle ABC, similar to triangle. Okay, first we know that measure of angle A in the first triangle is equal to measure of angle A in the second triangle. So we write A corresponds to A. And here measure of angle E is corresponds to here AB, side length AB, its corresponding angle is C. Okay, so measure of angle C in the first triangle is equals to measure of angle E in the second triangle. So we will write E corresponds to C. So we'll write E here. So the last one B, it will be equals to the last one, which is angle D. So triangle ABC is similar to triangle ADE. Here the arrangement is very important. You have to put the corresponding angles opposite to each other. Measure of angle A equals measure of angle A, and measure of angle B corresponds measure of angle D, and the last one, measure of angle C, corresponds measure of angle E. Okay? And you write triangle ABC, or here I write it as triangle BAC. So A is opposite to A, B is opposite to D. I write B here is opposite to D, and C is opposite to E. Okay? And from 102, from similarity, so the area of triangle DAE over area of triangle BAC is equals to the square of any two corresponding sides. Here I write DA because DA is corresponds to, here DA is corresponds to BA. Area of triangle DAE is given, it's equals to 12 centimeter over the area of triangle BAC. We want to find this area is equals to the corresponding sides. Here DA over BA is one of the ratios, which is equals to 2 over 3. So it will be 2 over 3 power 2. Put it in the simplest form, equals 4 over 9. Cross multiplication, so the area of triangle BAC, it will be equals to 9 multiplied by 12 over 4, which is equals to 27 centimeter square. Okay, you can see in this example that we used theorem, the third case of similarity, with the area of triangles. Okay, let's go to another example. Example 5. In the opposite figure, ABCD is a triangle in which AX equal 4, XB equal 6 centimeter, AY 5, YC equal 3 centimeter. Find area of triangle AXY over area of triangle ACB. Okay, and this is the figure in the opposite figure. Okay, let's first solve it together. Here, find area of triangle AXY over area of triangle ACB. So to find the ratio between the two areas, first you have to prove that the two triangles are similar. So we want to prove first that the two triangles are similar. How we are going to prove that the two triangles are similar? The first triangle is AXY. This is the first triangle, AXY. And the other triangle is ACB. Okay? You can see that angle A is a common angle. Angle A is a common angle. Okay? You can see that angle A is an angle of triangle XAY, and angle A is also an angle of triangle BAC. So angle A is a common angle. What about the enclosing sides? Here the enclosing sides, one of them is 4. I will write it here for you. One of them is 4 centimeter and the other is 5 centimeter. Okay? And what about the enclosing sides of angle A in triangle ABC? The first one here is AC, 8 centimeter, and the other one is AB, is 10 centimeter. So we will write 8, okay, under 4, the smaller side in the first triangle, and the smaller side in the second triangle is equals to 5, the larger side in the first triangle, and the second one will be 10, the larger side in the other triangle. Okay, so we will write AX. Here you can solve it by using the problem itself. AX over AC. AX is 4 centimeter over AC, which is 8 centimeter, so the ratio will be half. Okay, and XY over BC, we don't know XY over BC, so we will write AY over AC, AY 5 centimeter and AB equals 10 centimeter. This equals to 5 over 10 and its ratio will be half. So we have a common angle. An angle in the first triangle is equal to an angle in the second triangle, and the ratios between the corresponding sides are proportional. The enclosing sides are proportional and its ratio equals half. So the two triangles are similar. Okay, let's solve it again by using the PowerPoint. Angle A is a common angle. AX over AC equals 4 over 8 equals half. AY over AB equals 5 over 10. And this is also equals half from 102. Okay. Here angle A is a common angle. This is the first step. And AX over AC equals AY over AB. This is the second step. From 102, therefore, triangle AXY is similar to triangle ACB. So, area of triangle AXY over area of triangle ACB. Okay, let's write triangle ACB. Area of triangle ACB. This is equals to the ratio, the square of the ratio between any two corresponding sides, which is equals to AX over AC. And we all know that AX over AC equals half. So this equals to half power 2 and this equals to 1 over 4. Okay. So the ratio between the areas of the two triangles is equals to 1 over 4. Okay. Let's go to another example. Answer the following question. Okay. Let's solve some problem on what we have studied and we are going to complete our lesson. If two angles in one triangle are congruent, their corresponding angles in another triangle, then the two triangles, here you have that two angles in the first triangle is equal, two angles equals two angles in the second triangle. If two angles in one triangle are congruent to their corresponding angles in another triangle, this is similarity first case, then the two triangles are similar. You will write the two triangles are similar. Okay? If the ratio between the perimeter of two similar polygons is 4 to 9, then the ratio between the areas, between their areas is, we all know that area of triangle 1 over area of triangle 2 is equals to the ratio between two corresponding sides power 2. Okay? And the ratio between the perimeters of triangle is equals to the ratio between the two corresponding sides. Here the ratio between the perimeter of two similar polygons is 4 over 9. So the ratio between the areas, it will be 4 over 9 for all power of 2. So the ratio will be 16 over 81. So the ratio between their areas is 16 over 81. Okay. So we will write the ratio is 16 to 81, or you can write it as 16 over 21. Okay. Okay. Example 3. In the opposite figure, x equals space. This is the opposite figure and we want to find the value of x. Okay. Here, the two triangles here, I have to prove that the two triangles are similar. Okay. I know all the three sides of the first triangle, but I don't know all the sides of the second triangle, so I can't use similarity second case. Okay, but here you can solve this example by similarity second case. We all know that measure of this angle is corresponding to the measure of this angle. Okay, the two angles are equal because the two angles are vertically opposite angles. Okay, so measure of angle 1 will be equals to measure of angle 2. The two enclosing sides will be 3. We have 3 and 4, and the two enclosing side will be 9 and 12. Okay, 9 and 12. Here the ratio will be 3 over 9. This equals to 1 over 3, and 4 over 12. So the ratio will be also 1 over 3. Okay, so angle equal angle, and the enclosing sides are proportional, so the triangles are similar. Okay, so 2.5 over x minus 3, this is equals to the ratio 1 over 3. Okay, 2.5 over x minus 3, this is equals to the ratio 1 over 3. Cross multiplication, so x minus 3 multiplied by 1 equals x minus 3, is equals to 3 multiplied by 2.5. 3 multiplied by 2.5, this is equals to 7.5. Negative 3 will go to the other side, so x will be 7.5 plus 3, and this equals to 10.5. So x will be 10.5. Okay. Number 4. This is a repetition of the example 3. In the opposite figure, the last example, in the opposite figure, ABCD is a parallelogram. E belongs to AB line segment. Okay, where AE over EB equals 3 over 2. So we will write as in the opposite figure, AE over EB equals 3 to 2. BE intersect CB equals F. Prove that triangle DCF similar to triangle EAD. Okay, here we want to prove that triangle DCF. Where is triangle DCF? The largest one. This is triangle DCF. We want to prove that triangle DCF is similar to triangle EAD. This is similar to triangle EAD. Okay? Okay. And find the area of triangle DCF over the area of triangle EAD. Okay? Okay. Solution. Here you know that ABCD is a parallelogram. So measure of angle A is equals to measure of angle C. Okay? Here measure of angle A is equals to measure of angle C. Two opposite angles in the parallelogram are equal in measure. We all know that each two opposite angle in the parallelogram equal in measure. So measure of angle A will be equals to measure of angle C. Okay? And you know that measure of angle D also is equals to measure of angle F, alternate angles. We know that AD is parallel to CF and DF is the transversal. So this is a Z shape. Okay, so measure of angle D is equals to measure of angle F. Now we have two angles in the first triangle is equals to two angles in the second triangle. A equals C, opposite angles, and the measure of angle ADE equals measure of angle DFC, alternate angles. So the two triangles are similar. Okay, so we are going to write that triangle DCF equal similar to triangle EAD. Okay, so triangle DCF is similar to triangle EAD. So the corresponding sides are proportional. DC over EA is equals to CF over DC over EA equals CF over AD equals to DF over ED. Okay, we just want the ratio between any two corresponding sides. Here we know the length of AE. AE is 3 centimeter. And DC, we don't know the length of DC. This is unknown. But we know that in any parallelogram, each two opposite sides are equal in length. And we know that AB, its length equals 5. So the length of DC will be also equals 5. So here DC is equals to 5 and EA is equals to 3. So the ratio between the areas of the two triangles is equals to the square of the ratio of two corresponding sides. Here we want to find the ratio between the area of triangle DCF and the area of triangle EAD. Here we have DC and EA. Okay, so we will write the area of triangle DCF over area of triangle EAD equals 5 over 3 for all power of 2. This equals to 25 over 9. So the ratio between the areas of the two triangles equals 25 over 9. Again, let's solve it together by using the PowerPoint. ABCD is a parallelogram. So measure of angle A equals to measure of angle C, opposite angles. And measure of angle ADE is equals to measure of angle F, alternate angles. So two triangles are similar. Okay, so area of triangle DCF over area of triangle AED equals the ratio between the squares of is equal to the square of the ratio of two corresponding sides. I choose DC and AE. And this equals to 5 over 3 for all power of 2 equals 25 over 9. Thank you so much. Until we meet again next time, goodbye and good luck.